The Alexander Cell Saga, Chapter 7b. Jim was a qualified electrical engineer and was head of the corrosion control for the Central Electricity Generating Board for many years. He had retired from work but maintained his interest in corrosion control and his position as the chairman of the committee, which he had just reconvened. We had a deep discussion about cathodic protection measurements, and he said that he supported my views and had encountered the same misunderstandings that I had. He told me that he'd spent most of his career trying to make people understand the true nature of the readings, and that he had been shocked by the inaccuracy and some of the statements contained in the National Physical Laboratory report on the Alexander Cell. I told him that there seemed to be difficulty in explaining the reaction of the cell in terms that were acceptable to the scientific community, but he said that he regarded the device as very simple, which undoubtedly achieved what I complained in my own patent application. He had been worried by the claims that Ed Littlewood's patent attorney had made, which were repeated in the MPS report. But having spoken to me, he was happy that there was nothing technically wrong with the Alexander Cell. He was good enough to write an indisputable scientific description of the cell, which helped me to understand the difficulty that I had caused by describing it in terms of electrical current instead of electrical potential. In fact, his description answered an awkward question that had been asked at the end of my presentation of the Institute of Corrosion Science and Technology in London. At last, a scientific explanation. He explained that the connection to the pipeline lowered the electrical potential of the whole cell to below its corrosion potential, and this had stopped the reaction at the anode. As the reaction had stopped, so the current stopped passing through the meter. If the potential of the ground was greater than the potential of the first electrode, the empty cup in the drawing, then current would pass in the opposite direction. The awkward question that concerned micro-corrosion cells on the surface of the anode, that's the inside surface of the cup of earth in the picture, and how could the Alexander cell indicate that these had stopped corroding? In the way that Jim explained it, made it clear that my cell was probably the only way in which it could be determined that cathodic protection had been achieved, because thermodynamic theory requires that the potential of the metal be lowered to its passive zone, which are shown in the diagrams produced by a fellow called Purby. This theory is demonstrated in the laboratory by a device known as the Daniel cell, which makes a voltage measurement possible in the way that cannot be achieved in field work. I had learned this from a book given to me by the NPL, possibly in an attempt to blind me with science, but it was full of complex formulae which had no practical application if you could not measure the values. Jim's explanation showed that all corrosion currents must have stopped if passing through the meter had stopped. this was not the case, then it was back to the drawing board for me, and nobody seemed to be arguing with him. At long last I understood the difficulty that others had in understanding the actual workings of the Alexander cell. To Jim and I, it was a simple device, but to others who had been disciplined to think in the way that caused confusion in this instance. Jim was concerned that the cell might be inaccurate if used incorrectly in confined spaces, such as laboratory experiments, so I redesigned it to overcome this problem. I also changed the specified materials to eliminate the brass, even though Jim assured me that this would not push the potentials in the wrong direction, as stated by National Physical Laboratory. In fact, he was surprised that they should make such an assertion, which could easily be demonstrated to be wrong.